Which one of the following molecules will have unequal bond lengths? Remember one point here. sp3d hybridized molecule is having unequal bond lengths. So directly the answer we can identify, that is PCl5, because PCl5 all the bonds are not of same type, because hybridization is sp3d in PCl5. In PCl5 hybridization is sp3d, like this trigonal bipyramidal shape, 3 equatorial bonds and 2 axial bonds. These are the equatorial bonds, 1, 2, 3. These 3 are the equatorial bonds, and these 2 which are perpendicular to equatorial bonds, those are axial bonds. Here 1, 2, 3 are equatorial bonds. Equatorial bonds. The bond angle between the equatorial bonds is 120 degrees. 4 and 5 are axial bonds. 4 and 5 are axial bonds. The bond angle between two axial bonds is 180 degrees. The bond angle present between axial and equatorial is 90 degrees. And here axial bonds, axial bond length is more than or slightly more than equatorial bond lengths. Equatorial bond lengths, slightly more than equatorial bond lengths, and axial bonds are weaker bonds than equatorial bonds. Because of that, PCl5 is more reactive. PCl5 is more reactive. Axial bond lengths are slightly more than equatorial bonds, and axial bonds are weaker than equatorial bonds. Because of that reason, PCl5 is more reactive. And here, why the axial bond lengths are more than equatorial bond lengths? Because axial bond pairs will experience more repulsive forces from the equatorial bond pairs. Axial bond pairs will experience more repulsive forces from the equatorial bond pairs. Because of that reason, axial bond lengths are slightly more than equatorial bonds and weaker, and PCl5 molecule is more reactive.